Hello everybody, and thank you, especially thank you Daniel for having me here, but also you guys. And my name is Lucian, as you have heard, and I'm a software engineer, and for the last 10 plus years I have been working for 1&1, so 1&1 Telecom, but from the offices in Romania. And functionally I'm part of the VoIP development team, the core of which actually is based in Germany. And today I will talk about Kamailio modules that my team uses and some contributions that we have had over the years. And I'm not actually the author by far. I'm not the author of all the pull requests that I will show you or the changes. So a big thank you to all the people that have worked throughout the years for 1&1. And let's get to it. And a bit of information about what the company I work for is. And actually in Romania we have this branch called the 1&1 Internet Development, which sits under this United Internet umbrella company. And the United Internet also owns 1&1 Telecom, which you might know that it's an important operator here in Germany. But it also has some other businesses, especially the mail and media business, and also the hosting business, which provides this Ionos cloud brand. And actually in Romania, 1&1 Internet Development has 200 plus professionals, and it's been there for over 20 years, and it's employing people for 1&1 Telecom, but also for the mail and media, and also I have colleagues working for the hosting part. This is the tech stack that we improve, that we use. You can imagine that 200 people have a lot to offer. And yes, we work in Agile team. We contribute to open source, and not only this project, but other projects as well. And yeah, we're present in different stages of the software life cycle. But as I said, I work for the voice over IP business of 1&1 Telecom, 1&1 Telecom, which is an important operator here in Germany. And I'm showing you some aggregate figures because the company is really big, and it has almost shy of 12 million subscribers. And this roughly translates to 4 million calls a day, or 28 million telephony minutes per day. So just to make a big overview of what's happening. And I thought about a slide, something to show you a big overview of what's happening. And I think it's not new for everybody that voice over IP solution relies much on Kamailio. You can see here for the balancers, but also the registrars and elsewhere the proxies. And we also employ media relays, and media relays, I think everybody guessed that we're using rtpengine. And also we have multiple databases, particularly we're using MariaDB and Redis. So this is just a big overview. And what I want to tell you next is some of my perspective of working for a 1&1 VoIP development team. And I'm trying to make a point. And the point is that, well, we work with Kamailio, we work with rtpengine, but what you don't see is that we have inside our teams multi-user test system setup, mimicking a live multi-data center setup. And we're using a custom tool to launch tests. And actually, we've written this, and it's Python and REST API calls over CP scenarios. Elsewhere, we're using automated nightly tests, Jenkins, and stuff that you might expect. And now, what are the job requirements? So actually, what's important to say is that I'm working for an operator. And when you're working for an operator, you're working close to IT operations, meaning that these guys are adamant about keeping systems stable. So this is very important to us, keeping systems stable, solving whatever problems might come in the configuration or in the code part. And yes, then we have to implement the requested features, but once everything is stable and stays there and it's put and it's in place. And also I find myself working a bit also on this test system that I'm talking about. Okay, So now going to the business, to the core business, there are some modules that we are traditionally associated with, and this the first one that I chose to talk about is the carrier routing module. And this is actually a routing module, which I think everybody knows. What it does is rewrite the request URI, partly the domain part, so that we know how to send the message further. And we selected it for routing. You have to know that it's like the custom to use longest prefix matching prefix, which actually this is what carrier route does. But we also use it for balancing, which other people actually are using dispatcher for. We're using carrier route. And I can tell you a bit of how data is organized or how you should think about carrier route if you want to use it. So first we get the data under a carrier, and the carrier, for example, would be, let's say, just giving names is not an example. For example, a carrier would be Telefonica or Vodafone, so all the route information or data information about that carrier is grouped under this carrier. And then we kind of logically split this carrier's information into domains. This is not SIP domains. This is particular to carrier route. And for example, what you can think of domains, because we're using it to do the balancing. If we want to do the balancing, we will want to send the messages, the invite messages to the proxies. So how we would use it, we would define a default carrier, and then the domain would be the proxy domain, because everything goes there. And for the registrars, we would have another registered domain. And if you bear with me, it will become more clear. And for example, load balancing is done like this. We have a config because it's easier to do load balancing with small informations. And we have the domain proxy. And then when we do the calls, the CR route, what we are doing, we know that we are processing an invite. So we call default route with the proxy. So we match here the information, and then carrier route just selects one of the targets and delivers to one of the other, to one of the proxies. So it load balances, and this is a use case scenario. And then for the proxy, you can appreciate that we get from IT operation many routes. For example, we have rules for routing exceeding 40,000. So there are 40,000 separate cases. And when we want to do the routing, first of all, we have to know the carrier which we are sending through. Maybe this comes from PDB. So this is like it's done. And then, for example, normal routing, we know, because this is how we organize the databases, that we send everything to domain 1. And if this fails, then we know that we have put the information into domain D and to domain 2. So we're matching first the carrier, then the domain. And then we're doing longest prefix matching for the username. For example, you have 04723, something or like this. And here you can have the same, 0423, something like this. And the longest matching prefix or prefixes are going to be bundled together, and then you choose from this stuff. So this is how we use it. And actually, carrier route has been stable enough for us that we don't have to bring many great changes to it. But what we have used it for, so we created the pull request for, is exporting these functions to KEMI. And the functions are, for example, CR user carrier or CR route. So yeah, let's do it. So what we thought about it, code something, see that it works, and then open the pull request. And we said this is the usage. So this would be the code that you'd see inside the Kamailio KEMI config, because we were using it from Python, and we were calling it like this, CR user carrier, and then some string referring to pseudo variables. So this is Python code, but it's also actually leveraging some Kamailio variables. But for us, it looked good. What could be wrong, actually, nobody knows. But Daniel was there to guide us and tell us what was wrong. And actually, by discussing with him, we got some learnings. So don't do like we did. So pass the parameters for the functions that we implement with as values that you get from the KEMI exports. For example, the from user you should get like this. And why should you get it via the Python KEMIs is because else you find yourself parsing some functions for runtime processing. So basically what are we fixing up the strings to get the internals of Kamailio parameters. So we're on the way we're allocating some memory, but we weren't, as to say, diligent enough to free the memory. So we're in trouble now, but Daniel spotted it. And of course, there are some the way that you should call your wrappers when you are implementing stuff is that the Kamailio config wrappers should be calling the KEMI wrappers and not the other way around, which was what we did. So don't be afraid to make mistakes. Just assume them and move forward. And now I'm going to jump to this user lock module. It's actually starting from the user lock. At some point we wanted to have a better redundancy, load balancing, and failover. This kind of is not that as important now because we have SSDs that are much faster and RAM is much cheaper and stuff like this. So, but anyway, this is a module that we use for user location, which is actually what registrars use. And this also has been a stable module for us, but because we work into this, for this operator, we have problems that normal people wouldn't think of facing. For example, some CPEs of Einstein's Internet were sending non-standard IDs for the CPEs inside the multi-registration context. So this somehow interfered with the normal implementation. And someone has to adapt this stuff because it's affecting multi-registration, you can imagine. So this is one thing we strive for. And give it to an operator to find out that daylight saving time, during daylight saving time from summertime to winter time, you lose an hour, but you also start losing context because somehow you think you have to delete contacts earlier because 3 is 2, and so things move, something like this. And actually, if you'd like to, I don't know how interested you are about user lock, how it uses, how it works, but actually you have a lot of location databases, and you would group them by ID. And when a registration comes, you compute a hash over the username and the domain, and then you would get two separate DBReg machines where you do the writings. So you have your writing split in some machines. It's some kind of a sharding. And then when you do the reading, you start to doing it from one database. And if that's down, then you always have the other one. And this is how it works by and large. And actually, I'm going to go fast, and I'm going to tell you about rtpengine. And I also already told you that we use it as media relay. And actually, why you use it is why do you need media relay? For us, it was quality of service because carriers, other carriers that we worked with, requested some aggregate batches for the media. So they wanted, in order to prioritize voice over data, they needed to get some IP bundles. So we went with rtpengine because it integrated already with Kamailio. It was also open source, and actually it was a pretty good idea. And if anybody is interested, rtpengine just inserted itself in the SDP so that the media traffic goes through it. But I won't enter into details now. What I can tell you is that, okay, we have Kamailio, which is great, the Kamailio rtpengine modules, which talks to rtpengine, and it has a database with the rtpengines which are available, and you can select the one which is present there, and you kind of can ping them, and if one's down, then you want to use it, and you will know some kind of a failover. This is all fine and dandy, but what happens actually when, imagine this scenario that you are in the middle of the call and the rtpengine drops from from some reason it core dumps or something like this, then you're in trouble because you have a deadline. So of course you wanted to implement some kind of we wanted to have some kind of a failover in this scenario. And what we went for, it was syncing the session information between multiple RTP engines. So what happens is that when RTP engines start being in the middle of calls, they write session information into a database, and we selected the database to be Redis. And Redis provides this idea of key space notifications. So one RTP engine, if you have two Redis, one Redis can connect to the other one and say whenever you start adding information, then notify me about this information. And actually, we use this together with the High Redis library. So if we have two RTP engines, one will connect to the other's Redis and get the information so that it also can create sessions about the other one's information, as to say. And what we did next was this thing with BGPs, where one RTP engine actually has multiple IPs. So actually, if we think of two RTP engines, they both have the same IPs, but their priority is mirrored. So what happens if RTP engine 1 falls? Then obviously it won't be reachable, but the IPs on the RTP engine 2 can be usable, and then traffic would go there and actually find the right information on the RTP engine. And what I am trying to tell you is that we can create such a setup where we have what we call a pairing group. So this is RTP proxy 1 and this is RTP proxy 2, and they are configured like this, that you can see they share the same IPs, but they are in different orders, and one is registered to others' notification. Actually, you can think of an X. And yeah, this is nice, and it works for us, and we are able to provide failover. So this was a big stuff for us. And actually, we are still honing a bit this stuff. So we're continually adding to RTP engine. And also I can tell you that we're obviously interested in this RTP engine module, but I have actually the pull request that we worked on, but just to give you the big picture, we're interested in this node selection mechanism. For example, RTP engine internally uses a hash table to make some mapping, but it also uses database in which you say, okay, these are all the RTP engines that are available, and you have some parameters. For example, you can do the hashing by a hashing algorithm which you can change. But for example, you ping an RTP engine, then you wait for timeout milliseconds to retrieve the answer. If it's not, you are retrying. But how many times do you retry until you decide that this is not a good RTP engine? And when you do disable an RTP engine, how much time do you leave it there before you try to ping it again? And of course, you start pinging multiple nodes, but you have to, at some point, give up. So this is the queried node limit. And also, we have stuff that I think only operators who have a bigger setup will appreciate. So we have aggressive redetection. What happens when I find when RTP engine, Kamailio RTP engine module thinks it has no candidates to send the message over? Maybe using this aggressive redetection means that we can force each connection to redetect if it's they are up or not. And also there is allow op parameters, and somehow this allows to put an RTP engine. It's kind of a maintenance mode, so IT operations would like to take it down, but not then. But before taking it down, let every connection still in place to die out. So people buy, and then you can take it out. So this is the kind of stuff we're trying to improve. And as I said, I have the pull request, but this is the crux of it. This is what we're working on, actually. And yes, I went for a failed pull request because this is how we learn. I don't want to fail here with this presentation, but for the sake of learning. But this was, we wanted to fix the set selection. What happened was that at one point, when we were using RTP engines, but we in a fallback group, you have fallback groups in RTP engines, we just saw that the sessions, the RTP engine session would time out. Actually, every session would have 1 hour, 1 hour, 1 hour, what's happening. And actually, we're not sending the RTP engine delete message to the, it's not RTP engine delete, but this is the idea. We were not sending it to the correct RTP engine. So we knew we hadn't set the RTP engine set correctly before we call our RTP engine function, sending the delete. And we could implement this in code. We could implement this in the config. We didn't actually understand stuff very well. So we found this RTPP function call. And what happens here, at some point, active RTPP set is defaulted to 1. So that couldn't be right. And then what happened is that actually we're, because elsewhere we know we had set this active RTPP sets, and we said, can be right here. And actually, Daniel also, thank you very much, showed us the way. And this is for everybody working to Kamailio to remember that you are working on a multi-process setup. So if you have your invite coming and doing some ng offer, and then you get your buy, and this is doing the ng delete, this doesn't mean they are served by the same process. So you have either you have your active RTP set somehow in shared memory, or actually you're not doing something well, and this is how you should check that actually the message you are working for is the message you were working for with the ng offer. And so this is somehow the idea behind this. So please, okay. And we're also associating with the PDB module. It's also quite stable. And what PDB does is portability. And what portability means is you get from state organization, you get a CSV with all the numbers, and the numbers are allocated to some carrier. And this we might need for the carrier route to get the carrier. And what happens is that this CSV is processed by this PDB tool that actually parses it and creates data tree structures, and that then is inserted into the PDB server memory map there. And then Kamailio comes and talks, the Kamailio PDB module comes and talks with the PDB server and gets the information it needs. And we are interested in stuff like, we observe that for us, negative carrier IDs is not okay. Of course, it's not okay, but 0 would be valid. So we had to do this, and also make the timeout runtime configurable. This is some PDB module internal, but the lessons learned actually when working on this, I think it's a textbook approach when you're doing your commit and you're actually working on more modules or touching more components, that you have to do commits for each of them. Don't bring a big PDB commit and say that it works for everything. And that's that. And also, over the years, I think this was an important contribution that we had. We had a colleague who was knowledgeable in this SIP trace to the extent that he could implement this tracing method. This tracing method per message or per transaction or per dialogue. So we're using it actually to send information to Kamailio, and this is something very complex because it mainly uses a lot of dialogues and transaction module callbacks, and we know there are a lot of SIP possibilities that we can put them together, and this wasn't something mainstream. And yes, we also did other SIP trace additions. Another module that we worked on, but it's by no means ours, so not introduced by 1.1, it was this IMS. And at some point, we wanted to add TLS capability for this CDP, but also to export some KEMI functions. Actually, it's not that important for us. At this point, it's not that important to us. But yeah, doing the pull request, we also got some other information. Okay. And now, actually, what I want to tell you is some gotchas. And what happened is that some time ago, we started working with this KEMI. So here is why we have a lot of KEMI additions to our modules, or the modules we are taking care of. And I have a colleague who is more knowledgeable in this, and he showed me where you have to, when working with this, you have to choose your get functions, because you know what the problem is, what do they return, what data type they return to Kamailio from Python. So no, into the Python code, and it can return an integer, it can return the problem being what they return for null. They can't return the Python null, but they can return a Python string saying null. And it's a good idea when you do printing, of course, because Python doesn't react very well if you wouldn't get something there. But in if statements, it doesn't exactly, returning a string doesn't exactly evaluate to false. And actually, we find ourselves using f-strings a lot, because f-strings internally take care. These are Python specific. And this handle the formatting of the data, so it's not sensible to the num problem. Okay, and another problem that has been mentioned was setting dialog variables, because the dialog variables require string as values. So if you use these setIf functions, it's not for you. It's a problem because you're setting integer and you have to set, in fact, a string. And of course, when you do your KEMI exports, due to some variadic possibilities which can be used in the Kamailio config, and you don't find this in the KEMI export. So it's many functions. DS is from lists or lists with a number of parameters with a mode, with the URI, and stuff like this. Okay, and coming to a close, whatever these small gotchas that we have, we found this problem that we kind of stumbled upon. We were part of the code we have like this: if def with debug, and then do something. If not, then don't load those modules. And is it a good idea to define with debug 0, with debug 1? No, it's not a good idea, because it's defined and it will be used. So either you define it with this bug like this, or you leave it out. I don't know, put a space after the DS or something, and yeah. Remember to C-line your code. That can be done with commands or hooks. And okay, so that was it from myself. And thank you for having me again here. And if you have any questions, please shoot, but don't kill me.
Thank you. Really appreciate it for all these insights. And yes, just that with the dollar, because I was thinking with the KEMI to have the Kamailio variables on this Python Lua. But then, for example, Ruby use dollar for their variables, and then it's practically trying to expand to the native Ruby, and you'll have to escape it, not to expand it. And then I said, anyhow, by doing that, you make Python looking, again, like Kamailio config file with $fu and all the other stuff. So, yeah. Some people would prefer that one because they are used, but the new people are fine with the functions and more native for Python or Lua approach this without using $Kamailio variable. Okay, questions from the audience for Lucian? We have Ivan.
Right. So if I saw correctly, there was a config where one rtpengine was primary and it was a secondary for another node. How is that used? How is the secondary then activated? If
It's
if the
BGP.
primary of the secondary goes down? How?
Actually, it's BGP. So BGP at some point detects that one route is not reachable, so with a priority. So RTP engine 1 is down, and then the lesser priority goes to the RTP engine 2. I think this is what you're asking.
So it's BGP like for IP routing, or could be VRRP, could be another alternative.
I'm just trying to understand, probably it's the networking that I don't get. How is that node going to be still primary for itself, but primary also for the second one that went down?
Actually, it's a bit of mention to be made here. So when the secondary is primary for its calls, it will remain secondary for the other calls, so it doesn't write them into the database. So does this answer?
Yes, but when that primary for which its secondary goes down,
okay,
how does it take over the calls of that?
So actually, they are already opened, or what?
Yes, but the other, so for it to be in the first node, it has its own IP, right? For it to be in the secondary, there has to be some VIP, which is plain, for it to be secondary. And then how does it get the other VIP and have the two IPs running?
Yes, Linux. They'll come in. Non-local IP.
Uh-huh. Okay.
So you can see an IP that starts detecting at that moment, and then later you ship it to the system, and then it's automatically receiving traffic. That's kind of newish, like 10 years newish.
Okay. All right, thanks.
I'm not sure if it's that one. It's just like what I use it, for example, with dispatcher, two Kamailios with two IPs, one active, the other active, and cross backup. And when it's going down, the other will get traffic for both IPs. But if both are up, we'll listen on different IPs. But in listen, you have both IPs in both sides. It's just with the 2.6 and newer kernels, you have this non-local IP bind that you have to turn on sysctl. Okay. We can talk over a ping pong game. Okay.
Thank you.
You can find Lucian around, not to make it longer. Thank you. As you could see, good contributions.